Do you remember Jimmy?
He's a gingerbread man and he loves going around in circles.
Very inquisitive about his velocity.
Indeed.
And he's going around in a circle at the minute. But on our circle, he isn't a rocket or a jet plane.
He's not.
He's being held there by a string line.
He is. So if we draw this from your angle, so
Yeah.
that is Triff's finger, and then this is the rope attaching to the gingerbread man.
It's a nice gingerbread man.
I think so. And he's going round in this circle like this. Then because we know the centripetal force at any point, which we did in the previous video, is going to be acting towards the centre at any point in the circle.
But in this example, the centripetal force will also equal the tension in the red rope string there.
It will indeed, because it's going that way, it's the same way as the string, and that's the resultant. It has to be tension.
Yeah.
So these sorts of scenarios, when it's attached to string or some sort of cord, we can say instead of F equals mv squared over r, T equals mv squared over r.
Now that's fine for that example. Relatively simple, but it was more important for examples like that.
Now this looks a bit like those rides you get when you sit in like a giant swing and it takes you up really high and starts to spin you round.
And that's essentially what Jimmy's doing, but we're going sort of like a pendulum motion.
So this is now the string attached to our gingerbread man. He's a bit of a fatter gingerbread man.
He's gained some weight, been eating too much ginger.
But now he's going round in like a circle into the board. So this is an invisible line downwards.
Yeah.
He's going around in this sort of circle from above, as you can see with Triff.
But the forces aren't as simple because the centripetal force is still going
Towards
central.
the centre, because this is the circle it's travelling in.
Yeah.
It will always be in towards the centre of the circle it's travelling in.
But that's not along the same line as our rope or string.
And we say that this centripetal force is the resultant, but when you've got angles, it's not quite going to be that.
No.
If you remember in the previous video, when we were at the side of a circle, when you're at the side of a roller coaster, the centripetal force is perpendicular to the weight, and in this case it's at an angle, so there is still going to be tension. There's still going to be a tension here, T.
And it will be different. So I'm going to put Jimmy down for a second so I can write things.
That's a good idea.
There you go, Jimmy. So there's a few more things we can draw on. So not only will we have our weight, which will be down.
Yes, I haven't labelled that yet. Weight of the gingerbread man.
Or that's centripetal force. Yeah.
Yeah, we'll call that F
Or
C,
sorry.
whatever.
And we'll also have an angle.
And these things are going to change depending on the thing, but we can work out this tension force.
Yeah. Now, there's two ways of working out our tension force, using this line or that line.
Yeah, and it's going back to your triangles. Remember how to triangle?
Yeah. How to triangle is good. Lots of trigonometry in physics, especially this section.
What I'm doing here is I've just taken out this triangle.
Yeah.
So it's less of an awkward drawing now. So this is still T.
Yep.
This is still theta.
Our vertical component is weight.
Yep, so our weight, rather than just being underneath it here, it's just a completed thing. So
Yeah.
there's weight there.
Yeah, and our bottom, our centripetal force, C.
So, as Triff said, we can use our triangle things
Yeah.
to work out T in respect of two different sides, depending on what you know.
So, if you're doing a SOHCAHTOA,
Yeah, so
good thing to level out your triangle early on, I think.
yeah. So this is opposite,
Yeah.
this is adjacent, and this is our hypotenuse. That's what we're trying to work out.
Yeah.
So sum on head. So it's T
Sine theta will equal our centripetal force, but our centripetal force will equal that.
mv squared over r. So we can say that.
Yeah. Then if we want to use the other line instead, we will have the other one, which is T cos theta.
T cos theta and equals weight, which you know is a product of mass and g.
Yeah. So it becomes mg. But wait, got a question.
Good question.
What if you don't know tension, but you don't want to find it out either?
If you don't know T and you don't want to find it out, that you can put these two together, and T's will cancel out, and you'll end up with something else. Let's give that a go.
Let's give that a go. So if we divide this one by that one,
Okay. So I'm just gonna
put
do
a
that.
line. Yeah,
Put a
that's a
line.
good
We're
idea.
dividing that. These T's are going to cancel.
Yeah.
And you're going to have sine theta over cos theta, and that's going to equal mv squared over r over mg. which is the same.
Which will also cause cancelling.
Yeah, it's the same as mv squared over r times by 1 over mg. So mv squared over mgr is what it will come out to. And then those m's will cancel, but we'll do that in a second so you can see what we're going on.
Yeah, that's a good idea.
So these t's
Wednesday.
are cancelled, and
Yeah.
we're left with this.
And these m's will then cancel.
And I've noticed sine theta over cos theta actually equals something else rather
It
generally.
does. It equals tan theta, which then we can finish it all by saying tan theta.
Equals v squared over gr, which I've wrote up there.
Yeah, that's handy. It's like you knew what we were going to do, Wayne.
Oh, something like that.
Yeah. And this is a very useful equation because you can work out with relatively little information your velocity.
Yeah, because you'll either be told the velocity in the circle or the radius.
Yeah.
You know g, and you'll probably be able to know the angle. Or you'll know both the velocity and the radius and work out the angle.
Yeah. And then from the angle you can then work out the tension.
So this isn't given to you in your formula booklet.
No.
So sort of remember these steps if you can. It'll be
Yeah.
useful because then you're remembering this, this, and this for your exam.
There's lots of things to remember there.
But this is the sort of question you might be asked. It's not always simple circles is the main point.
Yeah.
So now I really fancy some ginger.
I do. Like, always when Jimmy's in a video, I just want to have some gingerbread. Should I grasp it?